What you are about to witness is one of the most insane things that has been created in this game so far. And at the same time, it is almost the most useless feature in the game as well. Here, we will be looking at a working and functional dungeon map, with compass included. The amount of code and work that goes into making this is just disgusting. But before we get into that, let's just start and nice and easy and just enjoy the fully working and functional map here. As you can see, the moment we grab it from the chest that it's supposed to be, this used to be just like a heart or something before. It is now an actual dungeon map item. If we hold it and we switch between floors, it will in fact update while we move. This is also applied when we go through this room here. You can also hold it in your offhand, it's very nice. It does function the same as a normal map, but if we go through this room, you will notice it does in fact update there. I've had a black box to this corner this whole time, oh my god. There we go. Let's try that again. I can't do anything without something going wrong. My god. We see the map. We can put it in our offhand. You can actually see it this time. If I'm holding this and I walk through the door, you will in fact see the room updates. Additionally, if you right-click the map, you can actually switch between the floors. Very conveniently, you can see the floor level that you were on the bottom right, and if we right-click, we can cycle through them. If we're on a different floor and we switch, it will focus on the one that we're at. Next up, I'm going to go ahead and pretend that we just completely removed the map. We've never collected the map. We are going to collect the compass here. Technically, I could go to, I think, the third floor room and grab it there, but it's nicer just to give it to myself here. So if we give ourselves the compass, it will give us another dungeon map, it's same as the other one. The actual compass item in the chest will still look like a compass, but it will give you the dungeon map because it does have to fundamentally work that same way. But you'll notice that we don't have an actual map anymore, but we do have the compass, or the chest icons. So again, since we don't have the dungeon map, this is as if you had the compass only. So if I right-click through the floors, you can see all the chests on each floor, as well as where the boss room is. And with the final bit here, if we go ahead and open this chest, we take the map, we now have the fully completed dungeon map, and you can see the chest that we just collected is in fact overlaid with a black box to indicate that we have opened and obtained the item within it. This does in fact work for all chests, so if I go over here into the next room, if we grab the slingshot, pretend it actually gave it to us properly. Sometimes it takes a moment for it to update. Usually if you're holding the map while you grab the chest, it doesn't update right away. But let's say I grab this one here, and then I hold the chest, or map, you'll see that the chest immediately gets updated. Only other real, finicky thing, I suppose you could call it, is if I go between rooms, you'll see for just a frame, you can see the opened chest icon again. But otherwise, outside of that, it is just working flawlessly. This gives you all the information you need to know. The only real disadvantage is that there isn't an actual UI screen on the game itself here that shows a mini map showing your little yellow icon arrow. Because actually, in fact, in the original game, the map itself does not show you your specific location. It just shows the room that you're highlighted in. So that's actually pretty accurate to the original, outside of missing another map UI, basically. Aside from that, that is pretty much all the visible functionality. There is one more piece, which is that if we go through the entire dungeon and we kill all the gold skulltulas, 2, 3, and if we go to this last fourth one, and again, I'm not sure this updates if I'm already holding the map, but we'll find out. So once we have collected all gold skulltulas, one thing I'll actually note in addition is that our advancement screen has now been updated to show you each location's skulltulas. So once you complete an area, you'll be able to tell because the advancement shows that challenge icon instead. Before it used to just count it by numbers. Now it's actually counting it by location, so you know when you collect them all per location. If I go ahead and open the map now again, you can in fact see a gold skulltula token on the bottom right or left, indicating that you have collected all the gold skulltulas in the dungeon. This part's not super necessary, again, since we have the advancements, but it is a nice little extra touch. You've seen the fun part of this. If your interest was just seeing how the map worked and enjoying the functionality and being like, wow, that's so cool, I don't want to know how it works, I just want to be like, wow, then time for you to leave. Goodbye. Thank you for seeing the new implementation. For those that want the most disgusting technical deep dive of how this functions and probably watch me struggle in the process to explain it all, get ready, because this is a lot. This is the most complicated thing that's in the map so far. This beats even the adult to child switch thing. Oh my god. We'll start somewhat basic and simple. We're going to start with the actual art aspect of it, because each one of these maps I do have to create myself. For example, floor 2. we have the compass only version of floor 2 where it gives you just the floor number and the Deku Tree title at the top. That is one map. You have the second map, which is this room, but it's unselected. So if I go down here, this is map number 2. Map number 3 is selected for this room. Map number 4 is selected for that room, and map number 5 is that room. So for floor 2 alone in this dungeon map so far, that is 5 different maps for just this floor alone, which it adds up very quickly because there are, what, 4 floors in this dungeon? So I think this totals up to like 23 maps for this single dungeon alone. I'm currently finished art-wise with Fire Temple, and that one has been the biggest so far, being like 48 maps. So it's a lot. How I've been doing this in particular has been just basically recreating the maps myself through shapes and stuff. I tried finding like a way of like just getting the dump files and textures of the maps, but I have been very unsuccessful doing that sort of research. And even finding something that semi works for me usually still has like, I always forget the word that I want to use, but it's like a crunchy, like it makes it look really gross and like over texturizes it, I guess. The point is, if I converted this directly from this image into a map in Minecraft, all of this color of orange will like become very staticky and crazy. And I wanted it to be a lot more clean, as you can see in this version, where everything is like a nice smooth color. It blends in with the edges of the map really well. And then the actual rooms themselves are very clean cut and everything. So in order to get all of that achieved, I did have to manually draw out the maps myself using like specific overlays and such. So you can kind of see right here, this is a very simple room. It's a singular room. So I literally just had to use the pen tool and draw out the shape. Very straightforward, easy. What I can do from there is duplicate it, remove the stroke edge so that it's a little bit easier to move around, like there's no outline on this one, and then change the color. Boom, simple, great. It gets a little more complicated when you have multiple rooms like this. So for each space, I have to create the shape, the basic shape and everything. And then from there, I select each room individually, making it a separate layer so that I can export the full map each time properly. So again, like here's map 1, 2, 3, 4, 5, 6, 7, with the additional 8, one being without any of the information, just the floor number and text. You with me so far? I hope so, because this isn't even the complicated part yet. This is the part that just takes a lot of time and effort. The coding part, at least, is very quick to implement it afterwards. The time-consuming part right now from this point on is just making the maps. But anyway, once I get all of the layers and files finished, with the name and the bar at the top being what I need, I then move it over to this map final, which is the correct aspect ratio of a map. I believe it's 128 by 128. From there, I basically go through this whole thing and I just export each file map one at a time. So here's floor 1, whatever, or not 5F, it's like 2B or something. So we export it, we then highlight it, export again, we go to the next floor, export, room 1 selected, export, room 2 selected, export, room 3, etc. It takes forever. And that's not even the last part. The last part is that once we have it all, we then use some sort of converter, upload our file. Let's use Jabu Jabu. Yeah, let's use Jabba Jabba for an example. So we have the map image, we import it, shows our image, we select it, adjust color so that it changes it to correct coloring and everything, and then we give it the map index that it is. So basically, after exporting it, we then have to re-import it and then re-export it to get the finalized map and everything. Last but not least for this step, we have to then actually know the naming scheme of the maps, which is a little bit different than what you might expect. So before I was just going in a purely index form where it's like 0, 1, 2, 3, 4, 5, 6, 7, etc. Because the way maps work, they have to just be a positive value. Fortunately, you can skip numbers. So what we were able to do is that we like make some, and by we, I mean Curite. Curite did a lot of help with this. Shout outs to Curite, he's super cool. He's a wizard, mechanical wizard genius. But yeah, in order to like map out the map index a lot more effectively, what we did is we made it use 3 main values here. We have dungeon ID, we have map level index, and we have room index. So dungeon ID is of course Deku Tree. Deku Tree is number 1, all the way down to like Gan's Castle is number 9 or something like that. Map level is of course each floor in the game. The farthest down level is 1, 2, 3, 4, and 5. So that is the map level index, and then finally the map room index is how many rooms there are. So with compass, that is 0. With map unselected, be this one here, that's 1, and then from there it's the rooms is 2 and on. So like 2, 3, 4, which you can kind of see here. So that makes it really easy, because then if I needed to add in an extra floor, they wouldn't like get in the way of each other, which is super nice. It also gives me the first like 99 if I ever want to add different maps in the future. And basically it just allows everything to cleanly fit in here without getting in the way of each other. I don't know how long that took to explain, but that's the first step, and that's the easiest step out of this whole process. So far what we've done, we have created the maps, put them in the correct file format, and thrown them into the map world file with the correct naming scheme. I guess one more thing just to kind of make note of it. These icons right here are actually custom markers. So same as if you like placed a map in the world and you used a banner, I think, to mark a location. It's kind of the same thing as that, but with a custom texture. So fortunately, I did not have to make an additional like 10 maps per room based on where the chests were and whether they were opened or not. Fortunately, I could use markers for that aspect. We'll get into why that is also still complicated though. There are going to be a lot of things that I probably will brush by, so I apologize for not being very specific on every single detail, but I will go through over 3 major things that I haven't really ever talked about in previous videos, and hopefully that will kind of bridge the gap a little bit on what's going on in a few places here. Hello, post-production Rivero here to explain things better than past Rivero did. As evidenced by the fact that I'm over here, that was when you know that I am explaining something better than I used to. The first of the 3 important things that we were going to start with is what macros are. So macros are a way of passing information through a function to be used later on. Probably the most basic example I can provide right here is calling a normal function. So it'll call this function file called test, followed by some curly brackets with the ID quotations word. So if I run this, you'll see that it prints the word word. In this file, you will see a say command. So you could kind of see this say command being something like this. And these two are essentially doing the same thing right now. So this $sign at the beginning is just an indication that we are passing information like this for that specific command line. And then the second $sign is for the actual location of where that injection is going to occur. So confirm that it's a macro, then inject what that information is. In this case, it's just the word, like we said. So now if I were to reload this right now, it should print it twice here, word. If I change the name here, something else, word. So as you can see, it just injects it straight in there. There's a few other ways we can do this as well. We can do the same sort of function call, but instead we get the block ID of something. An example is chests. So if I did data get storage or block chest, we can see that there is an ID Minecraft chest in there. So if I run the same thing passing that block, it will print out Minecraft chest instead. The third way that you can inject information is by storing it in data storage first, which we've kind of discussed in previous videos before. I would look into it if you're not familiar with it already. But you can see this one, for example, right here. So data modify storage. Basically, we are setting title called test.id. We are setting this storage value here. So storage example, so it's another string. If we do data get storage game manager test ID, we can see that that is what's stored in that area. So if I run once again the same function here, and instead I run with storage game manager test, it will find that ID specifically similar to the chest here where it has the components, it has the ID within that NBT data. It will then print out the storage example that was saved in that test ID. There is an additional caveat to this. For example, if I do test ID as this part, it is then going to be looking for stuff inside test ID. So now when I press the button, it's going to fail because it's looking for something further in, like test ID or something else, basically. Just know that whatever you pass in the macro is what you're going to be able to get, nothing else outside of that. So whatever is inside test is what you can grab. You can grab ID, you can grab something else like a components similar to the chest, but you would not be able to grab test itself or something past ID instead. So you could only grab ID, you could only grab whatever else is saved in test, nothing further down, nothing before. And finally, for this example, this is just another example of that initial storage that we did where we just directly set the ID to something or whatever we want to name this. But this shows it more in action of how you can literally just inject your information anywhere in any command line. It is so overpowered and kind of disgusting to look at, frankly, sometimes. For example, in this case, I am passing as all players. So like if I did execute as all players, I can run a command that says hi and it prints it as us. Which in this case, this is kind of what I'm already doing right here. So execute as all players, run say hi. Instead, we are injecting that information. So what we're doing is we're passing this as all players and replacing it with this ID that we have it saved to. So that way we can basically skip this part here. So we can just literally insert code into the code. Probably a better example even than this is if I just totally remove this whole thing and then like add it all in here instead. So now we just have an entire command line running in here, except for the execute part. This is a really silly example, but you can see how this can basically modularize a lot of files so that you're running the same general stuff, but just inserting what we specifically need, depending on the situation. But yes, that is the main way macros work and all of its functionality for the most part. You'll see a lot of examples of this being used within this map, dungeon map example. Post-production Rivero will return. The next thing, which is not quite as important, is a lot easier to explain. We have a lot of return fail situations, which basically means if this runs properly and it is able to successfully run this command here, it is going to prevent it from running anything else in that file. This is just a very easy break method, which prevents like extra checks being incurred unnecessarily, and also prevents us from having to like check the same information multiple times over and over again, because then it doesn't actually have to check it at all anyways. So you'll see that a lot in these examples where it'll just return fail, which means it'll stop it from playing anything else, which is super nice. Finally, and again, this one's a very minimal thing here. There are situations like this where these like backslashes here, this is literally just a way of indenting the code. A good example is this one right here. So this is just a data modify command with npt data, the curly brackets. It's just been indented to make it super easy to see each variable and the value that goes with it. So yeah, here's kind of the exact example of what it would look like normally. This looks a lot more normal to what most people have seen, but again, it's a lot easier and more readable to see all the variables separated in these specific examples. There's one last thing that I want to talk about, which is how this is divided into 4 main categories. What the first section of this does is basically stores and remembers which location the player is in within the dungeon. The second part is actually using that information to then update the map when the player is holding or using it. The third part is initializing the compass aspect of things, being able to document where every marker and chest is located. And then finally, the fourth aspect is when you're actually opening a chest to detect whether to add a new marker indicating that that chest has been opened. 4 simple parts, very easy, definitely, 100%. Starting with that first aspect, the map where it stores the player's location, what we do is on tick, we check if they're in the Deku Tree, of course. And the first thing we do is we actually set it individually per each player. The specific reason that we do this for each player is because everyone's going to potentially be in a different location. Right now, for example, it's pretending that I am in Deku Tree. Someone else could be in Dodonga's Cavern, Jabu Jabu, any other location, and they would need a different map with different information. Just know that we're going to be storing stuff within player index 0, as you can see here. You can imagine this says 0.map.playerIndex. So once we have obtained the individual player, we then store which room they're in. If we are reaching a certain location that we are looking for, it will then overwrite the room data to update what map floor location we're on. For example, if I copy this coordinate right here, you can immediately see that we are at one of the entrance locations here, and it has correctly updated me to be in the room that I should be in. So same as this pressure plate right here, the moment I stand on it, it is going to update to the room that I should be in. How does that work, you may ask? Well, let's see. So once we land on that pressure plate, we will run this overwrite room data and pass a certain amount of information. So first, we pass the player index, so 0. We pass which level we're on. Third, it was the second room within that area. And lastly, it's in the Deku Tree. We see that that overwrite room data is then called here. The main part of this that you should remember is that we are just saving the player index, the map level, and the room index to use and call for later. The reason these sets are done here is similar to kind of how we were explaining how there's the limitations with the storage method. We want these all to be in the same exact location, because otherwise if they're in different locations, we can't grab it all at the same time. There's also a small optimization, so obviously if we go into this room, it's going to update to know that we're in this area. If we stand on the area where it updates again, as long as the room hasn't changed, it's not going to run everything a second time. So in this case down here, if we haven't changed rooms, we just stop here. We don't have to check anything else past that point. However, if it is a different room that we now need to update, we check to see if the player is holding the map, because if they are, then we do need to manually update the map within their hand. That is the end of section 1, where we store the information of the map data onto the player, onto the next step where we actually apply that information. From here, once we're inside this, it then checks which one we're holding it in to then save it into our further down storage. So on our specific player, index 0, within map, whichever hand we're holding it in is what's saved. This part here is more related to the part where when you right click, it kind of goes through a scoreboard cycle. So when this matches the highest number of floors, it resets back to 1 so that it cycles 1, 2, 3, 4, 5, 6. So that part's not super important for the actual overwrite room data here. That's more for if you right click the map, because this file actually gets called from that as well. But yeah, main thing is once we actually get the offhand set and we know which level we're holding, basically, so right now we're holding 2F. Then we finally set the actual map for what we should see. So if we do not have the map, but we do have the compass, we grab that variable that we saved for which hand we're holding, so weapon.mainHand. Again, this would be the example of item replace weapon main hand. We are directly copying that main hand that we're saving here and just inserting it into the command like normal. And then same thing here, we are replacing our main hand with a filled map with the correct information. This right here is the direct set from the map file name. So for example, 110 was the first map unselected. That would be number 1 here, so 111. Same thing, we replace the main hand here. We set the dungeon ID and the map held index, and then there's a 1 at the end. Finally ending with the selected map, depending on which one we have selected, is the map room index here. When we're setting the map here, this information is obviously already stored. Most of this information, such as the ID, held index, and room index, are being stored in the overwrite room data, which if you remember is being called when you are at a certain location. Hopefully at the very least you can sort of understand that we go to a room, we save the information of that room, we then apply it to the map at the very end if we're holding the map. Now we get onto the compass aspect of this, which is somehow even more complicated than the map. First things first is the actual initializer. We'll start with the chest aspect of it here. So when I run this debug file here, this basically just resets the entire location. So now that I look in this chest, boom, the dungeon map is there again. That debug file is what we're in right now here. What it does is it fills each chest location and then applies the stored item gets applied. Some additional information that I store here is the actual location of where the marker would appear on a map based on this chest. So this chest here is on level 2, and the marker specifically on a map is coordinates x37 z2 basically. Once we've created all the chests and stored the correct data, we then run this map load. This basically saves all of the map data as well as the marker. For the general information, we make sure we know it's the Deku Tree, we make sure we know the dungeon ID is 1, we make sure the lore is Deku Tree, which is basically just what it looks like when you hover over the map here. So Deku Tree in purple, that's what that is storing. Because again, with the set map is actually also including that as part of the macro here. Because this set map is not unique to any location, this is a modular file that can be called for any dungeon. Deku Tree 1 marker 0, this is the marker for the boss room, because that is constant, that doesn't have like any unique situation where it changes location, it doesn't get an overlay on top of it or anything. It's always on a certain floor as well, and it is the only one of its kind per dungeon. So that is just manually hard-coded and set with the coordinates that match it. The Deku Tree chests, this stores every physical coordinate location of each chest, which is all we need in order to actually like retain which chest has been opened, etc. Once we have these coordinates, we can get the data on the chest, which also gives us the compass or the map location, map marker location of it. So we've set everything that we need to for the Deku Tree information-wise. We then go ahead and actually update chests so that all of the marker locations for the chests are saved in storage. Again, this gets really crazy, so prepare. With this chest storage right here, this is considered an array. Each index in the array is one of these numbers here, so 0, 1, 2, 3, 4, 5. In this next file that we call, we actually save that array to a different part of storage. So this is basically the same thing, just under a different name. That way we don't overwrite this chest storage. We can use a temporary one that will then iterate through things. This unique map decoration index is one of the most awful things ever. A lot of this probably would have been simplified if this wasn't a thing. Essentially what the map decoration does is it is what is used to add the markers onto the map. In our example right here, we are on the first floor of the Deku Tree, the unselected room version. We have an arbitrary number right here with the type player, which is the marker that will show up. So we're basically just putting a player marker in the center of map 111. So as you can see here, that marker that we just created is in the center of the screen. Now, let's say I want to offset it by 20. You'll notice nothing happens. And that's because we've already applied a marker information to this index. In order to update that, I actually need to change that to be different because each one of these is unique. And the only way to update that is by completely closing the game, which is what I just did before this. That means once you add a marker on here, you can't actually remove or modify it in any way, shape, or form. That is why when we collect a chest, we have a black marker that's covering the original marker behind it. Otherwise, if we could, we would just remove it completely, which would be great. So whenever we're adding markers to the map, we have to make sure we're also doing this in a consistent index ordering. That way, even if we like reapply the same information, it's not going to do anything because it's already existent there. So that's basically what this lifetime scoreboard is doing, is it is saving 0 and 1 for the boss marker and the gold skulltula marker in the bottom left, and then on that map. And then from there, it makes sure every chest marker, it has a unique ID, which this gets increased every time a marker is added, basically. So now that we've saved the storage of the chests array to a separate thing for modification, and we've stored which marker we're starting at, we then run the iterate over chests file. It first checks that array of chests, make sure it's not 0, so we have chests that we need to go over. And then just like the name suggests, iterating over chests, we're basically going through every single chest individually to set the marker information that assigns to that chest. It's a little bit tricky to do this in Minecraft data packs, so what we do in order to iterate through them is to grab the first index in the array, do whatever we need to do within the next function and everything past that point. Once we are finished, we then remove that index from the array so that whatever is next in the list becomes the new first index, and then just run this function a second time, and a third and a fourth and a fifth. With that chest selected, we grab the XYZ location of it, and we store which unique ID it should have into its storage on top of everything else. So now it knows that this chest is in index number 2, for example, still. Since again, we still have the 0 and the 1 for the gold skeleton boss icon, this index chest specifically has the unique marker, or unique identifier as 2. When we get onto the next chest and the chest after that, that would be 3, 4, etc. So we've saved that, we've gotten the location of the chest, we finally add the chest marker by... This is actually a little misleading. This says it's adding the chest marker. What it's doing is it's actually storing the chest marker into storage so that when we call set map here, we can also set markers at the end. So once that array has been fully saved with all the markers for the chests, we then, when we go into set map from the original, whenever you hold the map or use it in some way, we run this function here where it sets all the markers at the exact same time. The way this is possible where we can set all of those markers in one command is basically doing an item modify. So instead of doing a give where we're applying a single map decoration, we can use modify to apply all of them in one go. But that does conclude this initializer for the compass marker locations and chest locations. I'm an hour in on this. I hope this video is not that long. Finally, last but certainly not least, is the actual check in order to identify whether a chest has been opened and the item has been removed. So I already had a method for detecting when you open a chest and identifying that chest's location using a raycast. That is kind of how the freeze chests work here. So when you open a chest and within that chest contains a freeze item, that freezes the player. We can use this functionality for dungeon checks, which basically what it does is it first checks if you're in a dungeon. If you are opening a chest, we run an initializer. What we do is we get the location of that chest, which we've already gotten from the raycast. Getting the chest location that we get from the raycast allows us to pass it through to the next function through the macro. So we can get information about the location of it, we can get the floor that it's on, and we can get the marker location and ID. After that, we add the chest to an array so that we can keep track of all the chests that we have opened. This is done for multiplayer considerations where multiple people could be opening different chests, and we want to make sure that all the chests that are currently being opened are still considered and isn't removed or overwritten. So we store that information, we then run a schedule. This is basically just a slow tick. What this does is it basically just checks every now and then to see if you're still near that chest and if the item within that chest has been removed. So if there are no chests that we are opening, go ahead and fail, stop it right then and there. But if there are chests that we are near and we are actively have been opening or something like that, we want to iterate over that chest. It's pretty similar to the one for the initializing of the markers. This one's just for the open chests in particular because there's that overlay marker that gets added on top. Once we do get the first potential opened chest in the array to check if it's empty, we then run a macro a second time basically because this schedule function basically wipes any information we previously had stored. So we have to re-grab the chest location, which we can get through the storage from here, to then rerun it so that we have that correct information stored in the macro to pass through. That part's really weird and confusing. It's just a dumb extra thing we have to do because we lose all the information when we run a schedule command. With that check being done, every second, basically, we are checking to see if we're far enough away from that chest. If we are far enough away, we remove that chest from the array. And the way that we were able to remove that chest from the array specifically is by saving these two variables. So we have chest.temp, that's the one that we're actively removing and iterating through. And then we have the entire array. We're saving the length of both those into a score, subtracting the two to get the index, and using that index to then remove that index from the array. A good visual that Curate provided me to showcase is that this is what it looks like maybe halfway through the chest.temp array. So we've iterated through chest 0 and chest 1. We are now on chest 2 currently. We are far enough away from chest 2 that it should be removed. So we go and grab the original chest array length, and those are our two variables here. So the array length that we want to get rid of, the first index of it, so that's 3. This one is 5. We subtract 3 or 5 from 3, and that gives us index 2, which in this case is 0, 1, 2. That is the index we want to remove from the original array. This is the end of post-production Rivero. Thank you, good night. If we're not too far away from it and it does still have an item, again, also fail, keep looping until we are either far enough away or we have taken the item. And then finally, if we have taken the item, we get the unique ID of the decoration marker so that we know when we add an overlay on top of the marker, we add a number that is not used, so that we can add a new marker to put on top. What we do next from there is we add that empty chest marker now that we've saved the information for it, or the unique ID that it needs, and then at the end we do that remove chest once again, because once we've emptied it, we have in fact removed that chest from the array. So add empty chest marker. This is very similar to the add the regular chest markers here. It's literally the exact same thing pretty much. The difference being that it's adding a black banner instead of an orange banner to overlay and cover it, using the coordinates that it saved from the chest, I think, itself, because that's what's on this right here, right? Yeah, x48 z16. That's what it's applying here, because we are passing that macro from before with block custom data. Did any of this make sense to you? Man, it's so much. I'm sweating right now. If Mojang ever changes the way maps function, I hope it either makes this easier or it doesn't totally break what we've done so far, because this was so much to create. How many files is this? 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Like 27 files to get all of this working. And that's not even counting like stuff that like sort of also like works in tandem with it. That's not super important to this like direct functionality. Like there's a few files that like are used to check when a Skulltula has been killed, like run the set map file or something like that, or add Skulltula to level. So there's even more to this technically, but that at least goes over the main sequence of stuff. The rest of it is usually like different versions of the same stuff I've shown you here. Yeah, I don't know what else to say, and this is just ridiculous. But it works, and it's so cool. Like, it's so unnecessary, and yet it's such a core thing at the same time. Like, this is so cool. The reason it's so important too, the reason I've decided to really like dig down and get this working was because it is a very nice feature for randomizer in specific, because it shows if you've collected all the chests in the area. Now granted, there's not really a way to do that in the overworld areas, but I don't think there is that in the original anyways, so that's fine. And it just, again, kind of like allows you to be very comfortable knowing, hey, I've cleared everything out of this dungeon. I do not need to revisit it anymore. And of course, for beginners, I don't know who would ever play this without playing the original first, but it adds that extra bit of like help and usefulness so that they actually know where they are within a location. Even for people that haven't played in a while, I'm sure it also would help, because then they get to see like where they're at location-wise. It's just a nice feature, even if it's probably going to be used and just immediately put in someone's inventory and they're never going to look at it again. With that, if you stuck around for this long, please appreciate this. That's all I ask. I don't want anything other than just to be like, good job. Good job, Curate. Good job, Rivero. We put so much into this. Please support us. We're dying. Anyway, I'll see you guys next time, hopefully for some more progress and not just some random niche thing that is just really cool. We'll see. Thanks for watching. Enjoy the rest of your guys' day. I will be enjoying mine. So, bye.